Good morning, my YouTube viewers. It's Crystal here. In this video, what we're going to talk about is the sign test. And we're also going to talk about nonparametric test. Because previously, we had been going over parametric tests, like tests that related to a distribution, such as a normal distribution, but you can also use other distributions for parametric tests if you like. So now, in the next several videos, we're going to be discussing nonparametric tests. So statistical analysis is a cornerstone of modern data interpretation, offering tools to explore, describe, and infer conclusions about populations. Among these tools are nonparametric tests, which have carved out a vital space in statistical methods. Unlike their parametric counterparts, nonparametric tests do not assume an underlying distribution for the data. This flexibility makes them indispensable in certain scenarios, particularly when the data are not normally distributed, sample sizes are small, or data types are ordinal or categorical. So what we're going to talk about in this video is we're going to discuss the sign test. So the sign test is used to test the median of a population. It compares paired data to determine if differences are positive or negative without assuming normality. And so I've got a little program that we're going to review the code for a sign test so you can see how you can make a sign test. So the first thing we want to do is we want to create our data. So you've got X, which is a vector of a whole bunch of numbers, 12, 15, 14, 10, 9, 11, 13, 16. And then you've got Y is a vector of the same length with a lot of numbers. So you've got 14, 14, 15, 11, 8, 12, 14, 18. And then so you've got the differences. So differences is D becomes Y minus X. So that's the difference between Y minus X. And so you've got your D non-zero becomes D square brackets. So that what you're doing is you're kind of like filtering it out. D does not equal to 0. And then so you've got D non-zero. And then you've got counts. So npos becomes sum D non-zero greater than 0. And then you got nneg becomes sum D non-zero less than 0. And then we're going to do the sign test. We're going to carry out the sign test on this data. So test becomes binom, so we're going to use the binomial distribution dot test brackets npos, so that's your positive numbers, comma, length of the non-zero. So basically the value of the positive numbers, which is the sum of the positive numbers over the length of the non-zero numbers, and P, which is your probability, equals 50%. And then we're going to carry out the test. So here's your exact binomial test. So the data is npos and the length of D non-zero. So the number of successes is 6. The number of trials is 8. The p-value is 0.2891. So the alternative hypothesis is true probability of success is not equal to 0.5. But since the p-value is 0.2891, you know that you're going to fail to reject the null hypothesis. So you've got 95% confidence interval, and the values are 0.349 to 0.968. And then you've got your sample estimates. You've got a probability of success being 0.75. So the p-value is greater than 0.05, so that means that you're going to fail to reject the null hypothesis. And basically, that's what it goes. So we're going to plot it. So counts becomes a vector of in pos and in neg, and then the names of the counts becomes a vector of positive and negative, and then we're going to create a bar plot. So counts, comma, color equals a vector of forest green and fire brick. Y limit, which is your limit on your y-axis, is another vector with 0 to, comma, the max of counts plus 1. Your main, which is your title, is your sign test, positive versus negative differences. And your Y lab, which is your label on your y-axis, is count of signs. And then we're going to put some text in there. So X becomes a vector of C bracket 0.7, 1.9, and Y becomes counts plus 0.3. Labels equals counts. CEX equals 1.2. You're going to put some more text in there. So paste 0 brackets, two-sided p-value equals, and then it's going to be significant brackets test $ p-value rounded to the third point. Side equals 3, line equals 0.5, CEX equals 0.9, and then we run it, and this is the chart that is created. So sign test, positive versus negative differences. So you've got a p-value, a two-sided p-value of 0.289, and you've got positive is 6 and negative is 2. So that means you have more positives than you have negatives. So that means the sign test is going to be positive because you've got more positives than negatives. So that concludes this video. The next video is going to be on another non-parametric test. So I hope that you decide to watch it, and I hope you get something out of these non-parametric tests that we're going to be going over.